There's a video that truckers can't stop sharing. A brand new Class 8 tractor, the kind that costs more than most people's houses, sitting dead on the shoulder of an interstate with its hazard lights blinking. Not crashed, not out of fuel, just crawling along at 5 miles per hour because somewhere, deep in its computer, a sensor decided the truck was no longer allowed to do its job. And while it limps along the breakdown lane, an old cab-over from 1979, running an engine older than the man driving it, blows past at full highway speed without a single warning light on the dash. So here's the question that's quietly splitting the trucking world in half. Why are working drivers ripping perfectly good modern diesels out of their trucks and bolting in a 14-liter engine that was designed during the Ford administration? The easy answer is nostalgia. Old guys, old iron, romance for the way things used to be. But that's not it. And the people doing this will tell you flat out it's not it. The real answer is sitting in the price of almost everything you bought this week, and it has at least 4 layers to it. Most people never get past the first one. But to understand why a 50-year-old engine is suddenly worth more than the truck around it, you have to start with what everyone gets wrong. The first thing everyone says is that old engines are just simpler. And they're right, but they have no idea how right. The engine at the center of this is the Cummins 855, better known as the Big Cam, a 14-liter cast iron inline 6 that first rolled off the line in 1976. It doesn't have a computer. It doesn't have sensors voting on whether you're allowed to drive. What it has is the pressure time fuel system, a purely mechanical setup where the camshaft itself actuates the injectors and a set of spinning flyweights governs the whole thing. There's no software in the loop because there's no software at all. And here's what that actually means on the side of a frozen highway at 2 in the morning. A driver with a big cam who loses power can often diagnose it, reach in, and fix it with hand tools and a flashlight. Try that with a modern emissions truck, and you'll be waiting on a tow and a dealership laptop. That difference isn't a hobbyist's preference. It's the difference between making your delivery and losing the load. This is the engine that built the modern Cummins empire, by the way. In 1975, Cummins held about 29% of the over-the-road engine market. By 1983, on the back of this exact engine, that number had climbed to 63%. Drivers discovered these engines would run 1 million miles and keep running, which is part of why so many are still alive today, half a century later, waiting to be dropped into something. But simplicity by itself doesn't explain what's happening now. Plenty of old engines are simple. Plenty of old engines are reliable. That's not enough to make a working professional throw out a truck worth $250,000 and go backwards in time on purpose. Something has to be pushing them away from the new stuff that hard. And it is. Because the real story isn't about what the old engine does for you. It's about what the new ones do to the people who own them. Here's what changed, and it changed fast. Starting with the 2007 model year, the EPA required every new heavy diesel to carry a diesel particulate filter, DPF, to trap soot. Then, in 2010, nitrogen oxide controls became mandatory on 100% of heavy-duty engines, which meant selective catalytic reduction, SCR, fed by a tank of urea called diesel exhaust fluid, DEF. On paper, cleaner air. In practice, a brand new machine that can turn on its owner, because all of that hardware is monitored by the truck's computer, and when the computer decides something is wrong, it does not politely suggest a repair. It punishes the truck. Run low on diesel exhaust fluid, or trip a fault in the DEF system, and the engine can derate, cutting itself down until the truck is crawling at 5 miles per hour, sometimes after as little as 4 hours of running. Picture that. A truck that cost more than a house, capable of pulling 80,000 pounds, reduced to bicycle speed in the fast lane because a $20 fluid sensor threw a code. And these aren't rare gremlins. When investigators pulled the fault data, they found that 60% of all repairs traced back to the regeneration cycle, the process where the truck burns off trapped soot, and that the SCR system fails more often than any other powertrain system on the truck. Owners running these emissions trucks have described the regen cycle itself as a fire hazard. And the bills are not small. A single DPF can run $2,000 to $8,000. An SCR repair can top $10,000. Add the labor, the towing, the days of missed loads, and one emissions failure can cost $15,000 to $20,000 and park the truck for the better part of a week. This is the part that connects to you directly, and it's sitting in your refrigerator right now, though we'll get to exactly how in a minute. So now you understand the push. The new trucks aren't just expensive, they're untrustworthy in a way that costs working people their livelihood. But that still leaves the strangest part of the whole thing unanswered. Of all the engines a driver could reach back for, why this one? Why a specific 14-liter design from the middle of the 1970s? To understand that, you have to go back to why the Big Cam existed in the first place, and the reason is going to sound like a contradiction. America in the mid-1970s was deep in an energy crisis. Fuel was precious, and Cummins needed an engine that squeezed more work out of every gallon. So engineers did something clever with the camshaft. They made it physically bigger, 2.5 inches across instead of the traditional 2 inches, and that larger cam let them shorten the window in which fuel was injected. A tighter, sharper burn. The result was an engine that made its peak torque down low in the revolutions per minute range, and it sipped fuel doing it, best-in-class efficiency for its era, with a 15% fuel economy gain realized across the late 1970s. It was also, almost as a side effect, nearly indestructible. But here's the contradiction, and it's the detail almost nobody knows. The Big Cam, the engine that has become the symbol of truckers rebelling against emissions rules, was itself the first Cummins engine built specifically to meet emissions regulations, the ones written into the Clean Air Act of 1976. The icon of the rebellion was born from the very kind of law it's now used to escape, and it represents a vanishing breed in one more way. The Big Cam is remembered as one of the last true variable timing mechanical engines before the electronics took over. When Cummins replaced it with the N14 around 1991, that successor came with electronic fuel injection, the first crack in the door that the computer would eventually walk through. So the Big Cam sits right on the border. The last great engine that answered only to the driver, built right before the machines started answering to themselves. And it was so good at its job that it outlived the very engines meant to replace it, which is exactly why those old mechanical hearts, the Big Cams, the early N14s, the Detroit Series 60 engines, did not get scrapped. Therefore, they became the raw material for something the people who wrote the emissions rules never saw coming. That something was called a glider. Picture a brand new truck, fresh cab, fresh frame, fresh paint, every modern comfort, with one deliberate omission. Where the modern emissions engine should be, builders dropped in a remanufactured pre-emissions heart instead, a rebuilt Detroit 60 or Cummins, with no diesel particulate filter, no selective catalytic reduction, no diesel exhaust fluid tank, and no computer waiting to strand you. A company in Tennessee called Fitzgerald Glider Kits turned this into an industry, building as many as 3,500 of these trucks a year at its peak. And the owners ran the numbers in public. Their emissions trucks, the ones with all the modern hardware, were getting 4 3/4 to 5 1/4 miles per gallon. Their gliders, running those old rebuilt engines, were getting 6 1/4 to nearly 7 miles per gallon, with almost no downtime and roughly half the cost to operate. Now here's the part you can feel in your own wallet. Almost everything you own moved on a truck, and every one of those trucks burns fuel and racks up repair costs that get baked straight into the price of the goods. When a fleet's fuel economy jumps 2 miles per gallon and its repair bills get cut in half, that's not a trucker's private win. That's downward pressure on the price of your groceries, your furniture, the box on your porch, the medicine at your pharmacy. The fight under the hood has been quietly inside the cost of your life this whole time. But the gliders ran into a wall. In 2017, the Environmental Protection Agency released a study concluding these trucks could emit up to 43 times more nitrogen oxides and 55 times more particulate matter than compliant ones, and that the pollution from just 10,000 gliders rivaled roughly 200,000 new trucks, almost a full year of sales. So regulators capped each builder at 300 trucks a year, and by 2018, the business was effectively dead. And yet, in 2025 and 2026, the ground shifted again. The EPA began rolling back the very derate rules that started this, and the Justice Department stopped pursuing tampering cases. So here's where you actually land. You opened this thinking you were watching a few stubborn old men cling to obsolete iron. But that brand new truck crawling along the shoulder at 5 miles per hour and the 1979 cab over blowing past it were never about nostalgia. They were a referendum on a single question. Who controls the truck, the driver, or the computer? The push came from emissions systems that can strand a $250,000 machine over a sensor and hand its owner a $20,000 bill. The pull came from a 1976 engine so well built it outlived its own replacements, simple enough to fix with a flashlight, the last great machine that answered only to the person holding the wrench. Therefore, truckers reached backward, not because the past was romantic, but because the past still ran. And it all lands in the price of everything that ever rode in a trailer to reach you. So the next time you see an ancient rig thundering down the interstate sounding like nothing else on the road, understand what you're really looking at. Not an old engine. A working person's vote for a machine that won't betray them. And if you think it's strange that they reached for an engine this old, wait until you learn why most of those rebuilt hearts weren't Cummins at all, but Detroit, and what that quietly says about the engine America actually trusts.